This is Baslercast, tutorials for Mr. Basler's physics class. This Baslercast tutorial will be looking at a freefall problem. Let's get started with a ball that is thrown up into the air. So it's going to leave the ground, thrown up with an initial velocity of 50 meters per second. And we're going to ask the question, when is this ball at a height of 100 meters? Now the first thing I recommend is taking a look at a graph of what the graph would look like for this particular situation. If you note this graph, the ball is going to start with its initial velocity of 50 meters per second. And then as it's thrown up, gravity is going to slowly steal away velocity. That's why this velocity is going down. Now the velocity still remains positive because it's going up. And all this area right here, the area underneath the line, represents the height, which is 100 meters, which we're interested in. Now that's a rectangle and a triangle that we're looking at for this section. Now in order to examine both the rectangle and triangle, we would want to use this equation. Y final equals 1/2 a delta t squared plus vi delta t plus y initial. Using this particular equation, we could substitute in the information that we know. We know that its final position, which we are interested in, is the 100 meters. It is going at 1/2 with the acceleration due to gravity, otherwise known as g. Its change in time is what we're looking for, plus the initial velocity given in the problem. It's 50 meters per second positive value because it's moving away from the origin. And its initial position was 0 meters because it started at the ground level, which is right here. Now when we substitute in the information, we want to solve for t, so we need to rearrange this equation to get it ready for the quadratic formula. What I did to get it set up like this is simply take the 100 over here and subtract it over on the other side, which gives you the equation that you see right here. Now for this particular part, we're going to use the quadratic formula, and we have to identify what is the a, the b, and the c. This first part right here is the a in the quadratic. The second part, the 50 meters per second, is the b. And the last part, without any variable attached to it, is the c. And so entering those numbers into the quadratic formula, you will get an answer. You'll get two answers actually. One is 2.73 seconds and the other is 7.4 seconds. And this is often a question that students often have is, well, which is correct? Well, it turns out they both are correct. The reason they're both correct is because we're answering the question, when is the ball at 100 meters? Well, this ball is being thrown up, and it's going to keep on going past 100 meters, and it's going to turn around, and then it's going to come back down and be at 100 meters again. So what we're basically looking at is the 2.37 is when it's at the 100 meters the first time, and then the 7.47 seconds is when it's at the 100 meters the second time. Now another thing that we could look at for this particular problem is how fast is the ball going when it is at 100 meters. We could simply use the equation a equals final velocity minus initial velocity divided by time. That equation, if we were to rearrange it, or substitute in the information, we'd have a, which would actually be g, final velocity minus initial velocity divided by to the 2.73 seconds. What I'm looking for is how fast is this going when it reaches 100 meters for the very first time. So this equation needs to get rearranged a little bit in order to solve it. Basically, we're looking for final velocity. That's going to equal the acceleration times the time, and we're going to have that equal each other, and we're going to not subtract, but we're actually going to add the 50 meters per second to this part right here in order to get our answer. Put a nice little blue plus sign in there. So we get this equation here, final velocity equals g times 2.73 seconds plus 50 meters per second. If you solve that, the g here is actually a negative number, don't forget. So that negative number times 2.73, adding that to the 50 meters per second, we get the answer of 23.246 meters per second.
And that's it for this tutorial. I hope you found it helpful and useful. Once again, thanks for listening.